Okay, now with us we have a new question here. Now it's a complete one on all what we have seen. So it says a particle is predicted with an initial speed of 40 meters per second at an angle of 30 degrees above the horizontal. I think you see 40 meters per second at an angle 30 degrees above the horizontal. Find the velocity after 2 seconds. Whenever you see this question, start by getting our horizontal initial velocity and then also get the the vertical initial velocity. So you say, remember, our ux is always given by u cos theta, and then our uy said is given by u sine theta. So you start from here, our theta, start from there. Our theta is 30 degrees. So I'm sitting here, our ux is going to be, and our u is 40 meters per second. Putting them here, we have then cos 30 degrees. Then here we have u equaling 40 sine 30 degrees. So here, our ux cos 30 is root 3 over 2. To divide by this, we get 20 root 3 meters per second. Then here we have our uy sine of 30, 0.5 times this, we get 20 meters per second. So we start by getting these ones always. Now from there, we can come to get our velocity. Remember, our velocity is always given by, after 2 seconds, means that now we have moved. So we have a velocity which we easily resolve into the x and then the y component. Now, this one means we want the horizontal, this one means we want the vertical component. So, we start with the vertical component, our v, y, we said, we are going to use the equation of motion v equaling u plus lt. Now, vertically, this one, the vertical motion, we said we're going to be adding now u, y, then vertical motion, this one like this. Our x is going to be negative d. So we have now a as negative d, then t. So this will be, this is 20, then minus 9.8. Now our time after 2 seconds. And this will give you 0.4 meters per second. When I want now the x component, my v x, we say now it's going to be ux plus a t. But we said our acceleration is 0 whenever we are adding our horizontal component. So our vx here is going to be u, which is 20 root 3, then this is going to be 0. So meters per second, as simple as that. Now our v, you can see that our v is going to be given now by root of v squared x plus v squared y, which will be the square root of, we put our, which is 20 root 3, the whole square, then plus 0.4, the whole square. So our velocity there is going to be, we press that on the calculator. This is that 4.6433 meters per second. So after 2 seconds, that's going to be the velocity of the particle. Its direction can get alpha equaling to tan inverse of vy over vx, which is going to be tan inverse of vy 0.4 over 20 root 3. And so our alpha here is going to be the angle is very, very small. So the angle is 0.6 6 degrees. So then we come to B, time taken to reach the maximum. So part B, time taken to reach the maximum. Say, reach the maximum when the velocity is 0, the final velocity is 0. And so that our time there was, okay, from B, y equaling to u, okay, for the maximum velocity, say, when you put here our dy, then minus dt. But maximum, our v at max height, say our v of y is 0. And from there, it's that now our t. So from there, we have 0 equaling to, this is v y. So we have our uy. From here, our uy. So our t, uy minus bt, and set our t is going to be uy over d, which we have calculated already. This is this 20 over 9.8. So our t here will be, if you don't know the formula, feel free to now revise them, 0.0408 seconds. So that's the time it's going to take it to reach the maximum height. Or you can easily just state that our time for the maximum height is going to be this over d. Then you put it there, as simple as that. When you come to part B, the one has to get the time taken. This is the time, the maximum height attained by the particle. So, part C, we say the maximum height. How do you get the maximum height? We say the maximum height is going to be u squared sine the squared theta, the whole over 2d. Hope remember that. So our u is going to be, our u from there is 40. U squared then sine the squared of theta, which is 30, the whole over 2 into 9.8. So the maximum height here is going to be, the maximum height there is going to be this one is going to be 20.4082 meters. That's the maximum height. Maximum height attained by the particle horizontal range. Then find our range. We said our range is given by u squared sine 2 theta, the whole over d, which will be now 40 squared, then sine 2 of 60. Okay. If I calculate for you that, and put, okay, our theta is 30. So this would be 30 degrees over 9.8. And so from here, our range is going to be I'm getting 141.3919 meters. So this is the range, and this particle is going to cover. Then the time it takes for it to cover that, we said our t. Remember our t, we said it's going to be 2u sine theta all over d, which will be 2 into our u, which is 40, then sine 30, the whole divided by 9.8. And so from there, our t, the time taken, time to the right, so that is going to be now always this time of flight is twice this time. In simple terms, whenever they ask for your time of flight, start we are multiplying this time twice. The time we used here, we're multiplying it twice. Because this one is u over v, so we are multiplying it just twice. Get this. Then the maximum range, then part E, we said our R max is going to be equal to u squared over v, which will be 40 squared over 9.8, which is going to be 163.2651 meters. So that's the maximum distance our particle can cover. I think it's bigger than that. R max. So when you know these things, I think we started by getting this formula. So please revisit it. It was lesson 2. So that's how we handle this question. I wish you well. Now in this lesson we are going to see what happens if they give them to you as vectors.